Hello. So last time in the last video, I did a whole lot of talking and no coding. So this time, I think I would like to actually do coding and maybe hopefully no explanation or really rabbit holes. So here I am in the directory of the project. I'll go into source and make and run all the tests. Okay. So uh, So I mentioned before that this has an entry point, so we start the program with the name new sort, and we have three commands. Check kanji database order, which makes sure that the kanji are listed in the correct order in the source file, and it does other consistency checks as well. It shows the keys that are available to use for kanji, and then it shows the last. Then it can also show the kanji that you will use for each first key. That's kind of interesting. So last rank contained. So here, it doesn't quite fit on the screen. Let's zoom out a little bit. Actually, no. I think what I should do is I'll keep this size and start a new window. Okay. So for the way you read this is that for the first for key one, you have you can press one and then the next key will correspond to one of these kanji. And so essentially, if you want to type in, say, some character, let me highlight it. Maybe you want to type this one, for instance. This means agony. Then you go over to the left and you see the first character is C. And so C would be the first key you type in order to enter in the kanji for agony. And as you can see, it's not quite the same number of kanji for the first key. That's because there's kana, which are also used, which are also input, and these are not listed in this output. In fact, that would be kind of nice if I change that eventually to show the kana as well. Uh, but um, but anyway, that's how you read this. And the first character here in each line, in the little square brackets, that represents, in the sorting order we have for the kanji, it represents the first kanji in that set. And so there's a way that you can consider these characters to have an order. Every single kanji is either greater or less than some other kanji based on this order. And then, so the one in the brackets on the left shows you what the first one is on that line. And then after that, it's sorted by I believe, frequency of usage. So the stuff that is on the left side, on the very left, is the most frequently used in that row. And then on the right side, those are the least frequently used in that row. And at the bottom, you can see that the total number of kanji here is 1,250, which is a little bit less than my calculation yesterday. But we don't really want to go into that right now. But essentially, this code covers 1,250 kanji with two keys, and will cover more with more keys. Maybe the rest will be four keys, which is fine because the rest are only about 3%, like we looked at yesterday. Only about 3% of the kanji used in typical text. Okay, let's go back. So, all right, let's see here. So So yes, what we want to do is we want to. My goal is to print out a kind of rather than just print out right here. We showed the first key for each row. I want to adjust this so that we show two keys. For each character, we show the two keys you need to input it. And these two keys will not be the best. They won't really be optimized. They'll just be kind of arbitrary. But for the first step, it would be nice to actually get kind of a barely working code, barely working mapping. And so we'll choose an arbitrary second character for each line. And so this is a this is being a tad laggy. I'm gonna have to pause this and figure out what the problem is. Hello? Okay, we're back. So I believe I've solved the lag issue. Now let's start coding. Opening the editor. So now I need to create a file, a new source file, which actually has the new command in it. Oops. Here we go. So first I'm going to declare it in my header file. And let's see here, sources. I think I can just add one here, right? That should be fine. Make map.c. All right, and then I do edit. Now this is a command, right? So, oh, that's fine. It's not a separate binary. All right, so now I will go ahead and edit, make this file. Int make map int c char arg v. Okay. xf printf. This is my wrapper function that automatically errors out if fprintf fails, which is not really important, but I wanted to do this for tests because tests use this function too, and I don't want print to fail when it's running a test. That could make a test look correct when it's really not. Say if it prints extra output, but the extra output does not actually get sent. So here we say hello make map, make sure this is going to work. I believe this is in compat.h. Compat. Or maybe it's util. Util.h is what it is. Okay, let's make that. Should work. Good. So now we want to actually use this, right? So let's copy this line. We're going to go to main. Yeah, main. And add this new command, new sort, make map. And the new command is in. So the command prototypes are all in a single file. This kind of makes things a little bit more convenient. And wow, looks like I have a strange argument order. Guess I'll have to be consistent. And const car. Okay. Make map. Okay. And then I'll have to add a check, see if this command was actually printed, and then if so, we run it. If argc equals 2, yeah, let's just do greater than or equal to 2, and make map, then we do make map. That looks fine. Make Right, I didn't delete that main.c. Delete that extra semicolon. Make. Okay, so make map. Okay, that looks very good. So, so now it's probably going to get a little bit interesting. So now, what do we want to do? We want to we let's see. Lam. So make map.c. So we're going to print out the mapping from characters to kanji. So we already have a command which gives the keys that actually are used for kanji, and we can probably use that. So that is in free kanji keys, print free kanji keys. Print. No, it's not there. Where is that file? Edit. Commands.c, I guess? No. Oh, right. I have these aliases to standard out and standard error for testing purposes. So commands will print to these streams, which are usually standard out and standard error, but during tests they'll be redirected to a file which we use to make sure the command was correct. So what are the source files we have, and where is, an easier way is probably to just grep. So grep for print free kanji keys in all files. And it's in main.c, romaji.c. Yeah, that's what we want, I suppose. Romaji.c. And it's not in the header file. So find romaji.c, print free kanji keys. Okay. So here it is doing the calculation it needs to do in order to print the kanji keys. So how are we going to actually grab this output, grab the results of this loop and use them for our own purposes? We'll have to factor out the logic, obviously. So I see that it's adding things. We're going to have to essentially add things to a list, which is cumbersome because I don't really have dynamic array support exactly in this code yet. I don't have like the utility functions for that. And maybe there's a simpler way. I could use a callback perhaps. But callbacks are also a little bit messy. The callback could just get the characters that it needs. So let's see. I think what I'll do is put these in an array and return those. So it looks like the well, it's going to be each element of the array is two keys, two characters here, and it's going to just return those. We'll probably put them in a dynamically sized array because we don't really know ahead of time. We don't really know when we start the loop how many it's going to be in there. Although we could just count it first and then return it, but that's cumbersome too. So let's just go ahead and create the dynamic array support, util.h. So this is going to be based on what I saw in the Git source code when I was working on it. So what I'll do is I will have a struct which which indicates the size of the array. Count, let's call it L, and size T, capacity, and what we'll do is we will say we will have a way to increase the size of an array. So then when we use it, we're going to have a array. We'll do something like this. It'll be like here's my array, and then we'll have a struct dynamic allocation of dynamic allocation, and then later on we'll do like add or grow by dynamic allocation the array and grow by 1. So it'll be something like that. But now I'm realizing that this struct is not a huge help exactly. So what I think I would like to do is I will just tell you if you want to actually use this, you're going to have to create an array with you have to create a struct which has whatever type you want here in the array field, and then the element and the capacity. And this will encourage a little bit more consistency in the way the code is written. And we won't actually declare this for the user, but the user of the library will have to use it. We'll have to create a struct with these named elements in them. So with that all said, let's define grow by grow array by, okay, and we'll say the array struct, in other words, the thing you're trying to grow, and the count. So I think that what we want is we probably want something like this. We don't want the word array to be too long, because and that's a little bit too prescriptive. I don't want to make people use such a long name, and then the word array kind of looks more special than it really is. So we'll just say you need to call this field L. So I will say here, let's document how to use this. Create a struct that looks like this. Let's say grow array by. Create a struct that looks like this. Let's add. I'm trying to do that visual editing where I add a. Why is it not working? I'm trying to add a certain prefix to each line. I thought it was Control V, isn't it? Control V, or maybe it's Shift V. Oh, I almost. Okay, there we go. All right, create a struct that looks like this. L, where type is any type you want. The count, the number of elements will be kept in count, and the capacity in cap. Cap sounds kind of overused, so it could mean a lot of different things, like capacity, like capability. So let's just call it alloc, and right. So by the way, the reason why I'm using this macro magic is because the type can be any kind of type, and I really want to avoid casting. I don't really think casting is something that casting is a bit unreadable, and it's error prone. So I'm just going to avoid that altogether. So I mean, casting in a I mean, what would you could make grow array by it to a function, but then you're casting you're going to be casting this struct to a different struct, and that just seems a little too open to error. Like, imagine if struct array was defined as void here, and it was really a struct. Then every time I'm passing grow array, I'm calling grow array by, I'm casting it to a different kind of array type where it's like, the user's type here. Well, then imagine if the user got it in the wrong order, then it's going to be totally wrong. So I just want to avoid. I think the most elegant way to do this is with the macro. And yes, it's kind of like you have to learn a new language to use them, but that's really fine. It's You can tell it's a macro because it's in caps, and you have to look up functions anyway. There's really not a huge cost to using them in my opinion. So so let's see here. We have so there's the case where there's already enough allocation, right? And we don't have to do anything. Let's so I think we usually like to do and then while false, or while zero. I'm not sure why that's the preferred way to do it. So it's kind of a cargo cult. But so we do while now if um, if count is equal to alloc, then this is the case where we need to grow it, right? So let's see. So here we'll say array dot element, but we probably got to do this. Well, maybe not. Anyway, realloc, and I think I have a function in util.h for reallocating stuff. Xrealloc array. Xrealloc array up here will crash if there's a failure, which is really what we want. So we'll call it xrealloc array, and the pointer is array. So thinking we don't really want to, I had an idea, never mind. So array dot element, and then the count that we want, the new count, will be array dot count times 2. By the way, we actually need array here and array here, and count and the size. The size, I believe, is the size of the individual elements. So size of array dot L, right? So that's fine. We don't need brackets here because it's just going to be one command. And so then we do array dot count plus equals 1. And yeah, I think that will do it. So let me make sure I know what realloc array is. I'll look at the man page. Realloc array. No. Util.c realloc array. It's based on realloc, and if pointer is null, then we give an error, which is fine. And yeah, that looks pretty good. So the point of this was to look up realloc. So size is realloc size. Oh, I see. Yeah, I was multiplying it before I pass it to realloc. So size is what I think it is. It's the size of the individual elements. Let's just fix that here. L size, and util.h, L size. Now, I would usually probably make that a separate commit, but I don't really feel like doing that now. So Well, I probably should do that, shouldn't I? That's the right thing to do. Let's fix the indentation here. So we have grow array by. Okay, so let's do git add interactive the util.h and util.h. Patch 1, is that how you do it? Patch 1. No, I don't think that was right. 5 for patch 1, and then so here we want to split this and only get element.size. Yes, stage that. And no, don't stage that. And then we're done. Quit. Then we add the C file. Actually, I think we can add all lines in here, right? See, we don't have any changes in here. Yes, yes. Okay. And now we can quit. Now if we look at this diff, this looks pretty good. We're just changing the array, the name of an argument. So let's make sure this builds. Oh, we don't want this. Okay, this builds, so I feel pretty safe about committing this. We'll say rename argument in x realloc array for clarity. Okay. And I have to take a break. Okay, I'm back for a little bit. So let's see. So we have this array allocation utility, and we want to make so we have that. Let's assume that that's going to work, and we'll go to back to where the logic is that we want to pull out. And so we have print free kanji keys. So now the fact that this is a function in romaji.c and not a command function exactly is kind of weird. But I don't know if I really want to worry about that right now. Let's go to, let's create, let's declare the function which actually will get the array. So it will be, so we're going to have a struct of keys to car key array, right? And this will have a array of 2 characters, elements where each element has 2 characters. So we want to say element, let's call it code, short code. We'll call it short code array, I guess. And so the deal is that we dereference, this is a pointer, so we can dereference it. And after we dereference it, we get an array of 2 characters. And I believe that's the right syntax. Now we do size t count and size t alloc. And I'm just realizing that I made a mistake here. We want to change alloc if we increase it. So we do need these curly braces, and we'll say new alloc equals, no, we don't have to do that. Array.alloc multiplied by 2, then alloc. And that looks correct. Now we are back here. So we're going to have a function which creates a short code array which gives you the free kanji keys. And all right, let's just return null and make sure this builds. Well, we're gonna have to move this to the header file, right? So let's move this to the header file. And struct short code array, and we have struct short code array free kanji keys. Edit, let's see. Free kanji keys. Okay, let's make sure that builds. No, it did not. Must have forgotten some backslash here. Yep, exactly. Forgot a backslash. Okay. Here I used a colon instead of semicolon. Alright, fix that. And that looks better. Okay. So we do a... I just feel kind of funny about returning this array. I think it's... Yeah, I don't know. Let's just go with it. Struct short code array result. The reason why I feel funny is because now I have to allocate the struct. I don't want to have to do that. So let's just pretend I didn't do that. So keys or codes, free kanji keys. And really, this should be called free kanji codes, I suppose. Free kanji codes. All right. Free kanji codes. Okay, that looks good. And we're basically going to base it off of this function above it. And oh look, I forgot my own coding style. I should be putting the function braces on that empty line by itself. So codes, let's see. So here we want to say grow array by and give it codes and grow it by 1. Then we want to add codes L codes dash count -1. This will add 1 to the end, and this equals, let's see, this equals, so the first character equals this, and the second character equals key 2. All right, that looks good. And growing array by, don't have to return anything. And I think that is what we want. So I'll rewrite this up here. So this is going to be struct short code array codes, and let's initialize to 0. And then we're going to get free kanji keys. Oh look, I already have a get free kanji keys function there. That's interesting. All right, because this just kind of fills in. This is different. This fills in a struct, which is more like a doesn't actually have the characters. This doesn't have this struct does not have the keys, like the letters of the keys. It's more like a kind of a very sparse, a very densely packed array here. which just indicates for each item whether or not it's used. So this is different. So I think that we're fine. We were right in creating a new function. And print free kanji keys. Okay, we can get rid of all this, and we say free kanji codes, address of codes. And so have a loop iterator, and for I is 0, I is less than codes.count I plus plus, right? And then we're going to do printf out, and that's the testing, the testing shim, or the testing seam. So then we print out %c percent. Oh, maybe I should make this a more like a null terminated string. Nah, I don't think so. So we do this. I think you can do %2s. Shouldn't that work? And codes-li. Okay. And I think I don't really like this name anymore. Maybe call it get, because it's not returning anything, so I don't really. It is more like an action at this point. So it's not returning a value, so I don't want to just call it what it's returning. I want to just call it what it's doing, since it's actually writing something to an output struct. So here we go. Free kanji codes. This is called get free kanji codes. And print free kanji keys. I probably want to write a test for this at this point. Print free kanji keys, that would be nice. And make command. Oh, I have to include command.c. Command.h rather. Commands.h, I believe. Is that what it says? Commands.h. Yeah, that's it. Okay. Get free kanji codes. Okay. Want to actually use the right name for the function here. And okay, this is a more like a not a pointer, it's a normal struct. Oh, I also want a free codes.l. All right. Codes.l doesn't have a member called L. Are you really? Doesn't? Ah, yeah. I broke my own rule about what to call this. This is called element. Okay, looking better now. Expected identifier before constant. Oh, okay. I did not. So I use CNT in two contexts. I use it as an argument name as well as a field name here. So maybe we'll call this grow count. And so yeah, this actually has to support growing by more than one, I suppose. Or maybe we can just say grow. It doesn't actually. It always grows by one, but then it's going to be hard to name it. So grow array by one. That's kind of awkward. At that point, it may as well just pass the value. Calling it append is kind of vague. Grow array by, I think, is what we want. The API we really want. So we're going to have to do array.count plus equals grow count. Right. And then here If it's too high, then we will increase the count. Then we will reallocate rather. And times 2 may not be enough. So if array.alloc is still less than count, then we will set it to count. All right. I think that looks good. Okay. So now where are we at this point? We're looking pretty good. So what we've ended up doing is just refactoring a function out into a separate refactoring a command implementation into a function, and we also created a dynamic array framework, a very simple framework for using dynamically allocated arrays. So now at this point we probably want to make sure it works. Let's just do it normally. Print free kanji keys. Oh, not print. An extra new line for each one. That's interesting. Why is there an extra new line? Let's look. %2s\n. Well, xfprintf. So if I delete the \n, this will have the right number of new lines. No, it doesn't. And it has extra spaces here. Oh, it must be adding an empty code in between each valid code. Go array by. So I must have screwed this macro up. Alloc times equals 2. Alloc equals count. Count plus equals go count. Okay, this looks. Let me change the order here. If alloc is less than, this is a little bit more intuitive. All right, array alloc. If alloc is less than count, then alloc times equals 2. And then if alloc is still too little, then we just set it to count. Then we allocate count. All right, we added to count again down here, which is not right. So let's go back. We do need the \n, of course, as you would imagine. Okay, so this print free kanji keys is kind of like a dinky little command here. It doesn't have a lot of machinery in it, but I still think that we want to move it to a separate file. So let's go to make file, and we'll say free kanji keys is a new source. This will actually have the command in it. And then in commands.h, we're going to actually rename this so it matches the real command. Free kanji keys, and free kanji keys, and then go back here. This should be Romaji. Better be careful here. I don't want to save it after I've deleted it. I can't really use Vim copy and paste very well yet. Anyway, so we go to free kanji keys.c. Yes, we paste the function here. Let's go back and delete it now. Okay. free kanji keys, and here include commands.h, and we need romaji.h as well. By the way, romaji refers to the refers to the kind of practice of having Roman characters that correspond to Japanese phonetic characters, Japanese kana. And I am saying ji, but sometimes when you input something in Japanese, you can type in the sound for ji as either ji or zi, and I just chose zi. So I know it looks like z, but it's actually pronounced ji, no maji. So this might build. Let's check. Free kanji code. Get free kanji codes. Romaji.h. Get free kanji codes implicit declaration. So it's not finding the header file, I guess. Oh, I need to import util.h. Let's try that. Print free kanji keys. Oh, this is kind of bad. It's actually running the test even though it didn't build. Implicit declaration of function. Free kanji keys. Okay, so we want to go to main.c. So the right, because I renamed it. Okay, so go back to main.h, free kanji keys, and here. Now I also want to make this match the other commands a little bit better. I don't really like the way it's different from, like, it's a oopsie. I don't like the way that it looks different. The trampoline looks a little bit different from the other commands. So I'm gonna unify that and turn free kanji keys. So free kanji keys command.h, make this return an int as it should. Let's put this in alphabetical order as long as we're adding stuff. And commands, free kanji keys.c has to return an int, and we'll say return 0. We also have to do the and down here we want to make sure there are no arguments. If argc is greater than then we do except printf error. I've been typing all of my messages in Japanese in the output. Maybe I don't know if I want to continue that for the live coding. So let's just continue it for now. So kisu o watasanai de kudasai. Please don't pass any arguments. Exit. And I've usually been picking random numbers for exit codes. So let's just pick a random number. 0 to 255. 200. And is 200 reserved? I don't know. Exit statuses. Probably need to have this like bookmarked or something. Exit statuses meaning. Exit codes with special meanings. No, it doesn't look like it's reserved. I think we're fine. So, okay, this looks pretty good. There was an error. Free kanji keys. did not pass arguments. Okay, so we go to main.c and argv plus 2, argc minus 2. Try again. Too many arguments. Edit. Okay, because I didn't update this thing. I didn't update the prototype. Free kanji keys. Undefined argument. Main.c. Free kanji keys. Maji.c. So in function main, this is Chinese, so I'm not very good at reading it, but undefined argument or reference. No, it means reference. That's what I was confused about. Undefined reference to free kanji keys. Okay, I must have mixed something up here. I did not update this completely. Free kanji keys, shared sources, free kanji keys. So shared sources, by the way, is things that are included in tests. And the stuff that's only included in the production binary and the test binary is just inlined in the sources and test sources function variables here. So shared sources. Edit. Because I didn't fix this name yet. That's why. Okay, that looks good. Now I'm very worried about why the make file is not stopping when there's a compiler error. That's pretty bad. Test all builds test in. Okay, because test does not depend on. Well, test depends on last rank contain and rank coverage test, right? And they do not depend on. So the tests don't depend on. Oh, I see. Because the tests don't actually compile everything. That's why it was working. Okay, so the make file is fine. Now, if I actually introduce an error into free kanji keys, for example, like error foo, and then does make actually return an exit status with error? Yes, it does. But this time it didn't run the tests. Oh, maybe because it didn't change, because when it was passing, when it was erroring out in the compilation and it passed the tests anyway, maybe that's because the sources didn't change or something like that. I think the make file is fine, but I'll have to stay alert to that in case something bad happens later. So this is, at this point, what I'll have to do next is create, well, let's see. I probably want to make a commit which does the refactoring, and then I will continue to commit the make map function.